Today is 20th of April 2025. The synchronization. There is a synchronization problem, which is producer-consumer problem that producer make buffer increase and consumer basically make buffer decrease by using them. It's also similar in Pintos alarm clock, the first project, because if you see this produce item has which is equal to sleep take corresponding to sleep leave. If not buffer is full, sleep request and update buffer index circular if index folder and incremented the number of sleeping incremented and consumer wait if thread wake up walk sleep lift unbound thread whose located update buffer index circularly. Maybe we could see like this, but I'm not sure we can really see like this. And also, if it is synchronization problem, there is solution, which is semaphore. In Pintos, there is sema down and sema up, which is doing disabling interrupt, and sema will go to 0 if semaphore executed. After that, we put current thread to waiting left and remove it. And for now thread awake, waking up thread. Flag will take awake, and there is semaphore, how it used it. Producer does sema up and consumer does sema down. And also, if I do very quick chapter 6 review, then so basically there is critical section problem, which is preemptive and non-preemptive. When you are in critical section, it is a preemptive or non-preemptive. And there's solution, which is mutual exclusion, progress, bounded waiting, Peterson solution, which using turn int or boolean flag to, if it is not PI session, then they will give first, or by giving the integer turn, so which process does it, whose turn is it, we can notice it. So mutual exclusion is basically who's in critical section. Anyone can't go in, and progress is if no progress is executing in as critical section, and there exists some process there wish to enter their critical section, then they can enter it. And bounded waiting is that other processes are allowed to enter their critical section after a process has made a request to enter its critical section and before that critical is entering. But Peterson's solution is not really using these days. Related with these solutions, we also have synchronization hardware, which is memory barrier, hardware instructions, and atomic variables. For memory barriers, they have strongly or weakly ordered. And for hardware instruction, there is test, unset instruction, and compare and swap instruction. And for atomic variables, they provide atomicity, but these are too complicated. So what we are using is mutex lock, but it sometimes occurs busy waiting, and this lock therefore called spinlock. And there is upgrade version of mutex lock semaphore, which has counting, same as mutex lock, but they have solution for no busy waiting, which is block and wake up operation by making wake up query. And monitor is high-level abstraction logic that you can actually have both things. If you see here, semaphore use only wait and signal, and mutex use lock and unlock. And by those things, we can see whether the liveness, which is related with deadlock concept. Thank you.